Hey all, so I wanted to make this video to go over to what we did today where we have a graph, and then from that graph we can figure out what the equation of the quadratic is using information on the graph. So in this case, we're going to keep in mind that our equations in factored form are y equals a times x minus r times x minus s, where r and s represent the zeros, right? They help us to find the zeros, those x-intercepts. So here in this first equation, I have an x-intercept of -1, 0, and I have an x-intercept of 3, 0. So in my equation, I'll write y equals a times x minus a -1, and then times x minus 3. The minus is part of the equation, so notice I did minus and then a -1 here because this minus is just part of the existing equation, and then we plug points in there. And so when I do this now, I can rewrite this as y equals a times x plus 1 times x minus 3. But what we don't know is a. We don't know what that coefficient is that's going to tell us how far we're stretching this, whether it has a vertical stretch or horizontal. And so what we're going to do now is use a different point to find out what a is. So this point is a point on the line, and so we know that that is a point that solves this quadratic, and that point is 2, 3. So in this case, x is 2, y is 3. So now I can plug 3 in for y, and anywhere I see x, I'm going to plug in 2. And so here we'll get 3 equals a times 3 times -1. And so then we get 3 equals a times -3, or -3a. And so when I divide both sides by -3, I'll get a equals -1. This means my coefficient of my equation is -1. So going back up to the original equation that I created, I can write this as y equals -1 times x plus 1 times x minus 3. And this makes sense because it's curved downward, and it's open downward, open facing downward. It's a frowny face. So we know that it would have to have a negative coefficient. In this case, that negative coefficient is -1. So to put this in standard form, we're going to do y equals -1, and then I'm going to work with what I have in parentheses first. So I'm going to go ahead and you can use your box method or you can use FOIL, but I'm going to multiply x squared minus 3x inside plus x last minus 3. So we'll get y equals -1 times x squared minus 2x minus 3. And then I'm going to go ahead and distribute that -1 through, and so we'll get -x squared plus 2x. -1 times -3 is plus 3. So y equals -x squared plus 2x plus 3 is our equation for this graph. Now notice this is a lot of work, and it means keeping track of a lot of different parts. So it's very important that you write things down carefully and make sure that you have all of the pieces that you need written down somewhere so you can keep track of them all. All right, now let's go ahead and take a look at this next second one. All right, so again, we want to make sure you have plenty of room to write. You're going to need that room. I'm going to write the equation again, y equals a times x minus r times x minus s. And again, it doesn't matter what you use for r and s, it's just those are the points we're looking at. So we have -10, 0, and we have -6, 0 as our x-intercepts. So let's start with that. Y equals a times x minus -10, and then x minus -6. So you know immediately we're going to rewrite this as y equals a times x plus 10 and x plus 6. And you can check that that works because x plus 10 equals 0 gives us x equals -10, and that is our our x-intercept there. All right, so let's take a look then at finding a. So now we have the equation. That's what we wanted, but now we need to find a. And so we're going to use a point. We have a point right here, right? That is a point that I can use. And so we're going to go ahead and say that that point is -8, 4. So that point is -8, 4. So this is our x, this is our y. So let's set that up. 4 equals a times negative 8 plus 10 times negative 8 plus 6. All right, well, let's give myself some more room here and go ahead and write this. 4 equals a times 2 times negative 2. So 4 equals a times negative 4. Divide both sides by negative 4, and you get again that a equals negative 1. Again, that makes sense because we have a downward open-facing curve. So now I'm going to go back up and replace a with negative 1. So y equals negative 1 times x plus 10 times x plus 6. And then you're going to distribute y equals negative 1. Start by using your parentheses first. X squared plus 10x plus 6x is plus 16x plus 10 times 6 is 60. And then distribute that negative through. So y equals negative x squared minus 16x minus 60 is your equation for this graph. And you can check to make sure that that's correct using your calculator. Let's look at the last one. All right, so that last one again, I'm going to, let's make this a little bigger. I'm going to go ahead and use that y equals a times x minus r times x minus s. Our points this time are negative 7, 0, and negative 3, 0, and then the point on the graph that I have is negative 4, negative 3. All right, so I have my points first, so y equals a times x minus a negative 7 is plus 7, and x minus a negative 3 is plus 3. All right, so notice I did some of that mental math there myself, but make sure that if you're messing around with negative signs that you're very careful. I know that a negative minus a negative is going to give me a positive. So now I can go ahead and substitute my x and my y. So we're going to go and substitute negative 3 equals a times negative 4 plus 7, negative 4 plus 3. We'll get negative 3 equals a times 3 times, in this case, this is negative 1. So we'll get negative 3 equals a times negative 3, and then this time a is just going to equal 1 because negative 3 divided by negative 3 is a positive 1, and so our equation this time is I'm replacing this a with 1, and so this would just be y equals x plus 7 times x plus 3. That makes sense. We have a positive coefficient because we have an open upward graph, and so this would be x squared plus 7x plus 3x is plus 10x, and then plus 21. All right, so that was just a quick tutorial on when you need to find the value of, find the equation of a graph. That's one way that you can do it, is to use those x-intercepts and then solve for a to figure out what your coefficient will be, and that will help you to find the graph that you need to create. In all of these examples, the coefficient was either 1 or negative 1, but that won't always be the case, and that's why it's important to solve for a. You can't just assume that it will be 1 or negative 1. You need to use what information you have to determine what is the coefficient. All right, that's it for this little tutorial. If you have any questions, you know how to reach me.